The Unigrid network and its design creates a foundation that other blockchain products can run on and utilize. Rather than implementing their own blockchain solutions, other blockchains can simply be hosted on top of the future Unigrid network due to its low-level design and segmentation. On the implementation level, these projects would only have to store their data directly, not having to be concerned about the implementation or the fact that the data is stored in a blockchain. When data is stored on the Unigrid network, it is sharded and divided into separate small blockchains, allowing the system to scale indefinitely with next to no degradation. Thanks to the low-level design, a blockchain network such as Bitcoin would be able to store its data on top of the Unigrid network. If Bitcoin was simply deployed on top of Unigrid, just tweaking the way the initial blockchain is downloaded, it would allow nodes to synchronize fully in a matter of hours or minutes rather than days or weeks. Furthermore, if the protocol was tweaked to handle a larger block size, it would easily be able to scale, handling many more transactions per second while retaining its security and flexibility. Rather than having to download and checksum each block individually, what if the data could be stored in a continuous data blob that could be directly downloaded? If the blockchain and the database was stored on the Unigrid network, the trust and the role of keeping the data consistent would move and become the responsibility of the network itself. Individual checks of each block would no longer be needed because the whole chain would be hashed and stored on the Unigrid network. Because services, logic, and data to verify the chain can actually reside directly on the Unigrid network itself, Bitcoin nodes would no longer have to rely on storing block and transaction data locally. This task would be taken over by the grid nodes on the Unigrid network. The node would then run the logic needed directly from the Unigrid network itself. Consequently, the memory consumption requirements, storage requirements, and complexity would drastically decrease, and the total storage needed for the Bitcoin network would decrease by several factors compared to today. When load on the shard group increases, the network rebalances, either creating more shard groups or growing the existing ones with more nodes. This allows the network to continuously adapt to increasing traffic and load, while at the same time wasting less resources than the traditional blockchain solution. With the design of the Unigrid network, other projects can store their blockchain in a more optimized manner, requiring less resources. This results in less storage space being needed to accomplish the same thing, creating a greener solution requiring less hard drives and less processing power. The low-level design brings down complexity and allows third-party blockchains to run on the Unigrid network without any understanding of the underlying implementation.